Hey everyone, I wanted to take a couple of minutes today and just finish up what we have right now for inverse functions. So normally you will not have new material in lab, but we are at the very tail end, a few other pieces of inverse functions before we move on to something else after test one. So the graph of an inverse function, you have already learned how to show whether two functions are inverses based on their equations. The graph of an inverse function is a reflection across what's called the y equals x line on the graph. So this is the line y is equal to x, and if I have a point on my original function f of x, let's say the point AB, then my inverse function f inverse of x contains the point BA. So the reflection across the y equals x lines means that you can swap the ordered pairs and get a point on the inverse function. There is a problem on the homework for you to pick out an inverse, but we're going to graph one today based on that property. So if I take a look at this function here that's notated, and I want to figure out what the inverse function is, I need some coordinates for these points. So if I take a look at this first point, for example, this is the point -4 in the x position and -3 in the y. So that tells me that the inverse function is going to contain the point -3, -4. So this point is going to be on f inverse. Now for notation or for your graphing purposes, I'm doing f inverse in blue. So now if I'm looking at the next point on the graph, then this looks like the point +1, -1, which would mean that the inverse would contain the reverse of that, or -1, +1. And the last point that I have on the graph of f of x is the point 2, 5, which means that the point 5, 2 is on the inverse function. So this would be the point 5, 2. Now the rest of the points we get from the reflective property of the inverses. So if I actually create a line that represents the y equals x line, this would be something that looks like the y equals x line. Everywhere that the original function crosses this line, we also have a point on the inverse. So on that line itself, it doesn't matter what x and y are because they're the same. So we would get a point on the inverse function as well. So really, instead of having 3 points to guide my graph, I have 5 based on this y equals x component. So then we're going to estimate and pen it in, and we get something that looks like this. Now if I am going to find an inverse function, then first I need to start with a function that's 1-to-1. So remember, a function has an inverse if and only if it's 1-to-1. Then I'm going to take these 3 steps here. So I take f of x, replace it with y, then I'm going to switch my x and my y components. This indicates the reflection over the y equals x line. And then I solve for y. Finally, notationally, I replace the new y with f inverse to indicate their inverses. If I want to verify it, all we have to do is create our compositions like we've done already. So I create f of f inverse and f inverse of f, and they both have to equal x if I want to verify. So let's take a look at a couple. So if I have this function f of x is equal to 4 over 2 minus x, then my first step is to replace f of x with y. So y is equal to 4 over 2 minus x. And now I'm going to switch. Oh, my iPhone is restarting. And then I'm going to switch my x and y components. So part 2 is to trade x and y. So everywhere I have a y, I'm going to write an x and vice versa. So x is equal to 4 over 2 minus y. And then I need to solve for x, or solve for y. want to solve this thing for y, I need to break y out of the denominator. So what I'm going to do is I'm going to multiply both sides by the denominator. So 2 minus y is our denominator here. On the right hand side, that cancels. On the left hand side, I'm going to distribute. So 2x minus xy is equal to 4. So then I'm going to go through and solve for y. So subtracting 2x from both sides, negative xy is equal to negative 2x plus 4. And then dividing by negative x, y is equal to negative 2x plus 4 all over negative x. So this is our inverse function, so f inverse of x is equal to negative 2x plus 4 over x. Now if I want to take a look at a different kind of function, g of x is equal to x cubed plus 8, so process is still the same. Y is equal to x cubed plus 8. Switching x and y, I get x equal to y cubed plus 8. And then I need to solve for y again. So subtracting 8 from both sides, x minus 8 is equal to y cubed. And then in order to solve for y, I need to do the opposite of the cube. So I'm taking the cubed root, and I get the cubed root of x minus 8, and it's equal to y. Now this time I started with g, so this would be g inverse of x equal to the cubed root of x minus 8. Now one little note on this, if you're going to enter this in web work for your homework, in order to enter that in, we know that a square root is a 1/2 power. A cubed root is a 1/3 power. So if I were going to enter this into web work, I would open a parenthesis, do x minus 8, and then I would use the up caret to get into the power, and open another parenthesis and have 1/3. Alright, last one, and then we'll let you get to lab. If I have f of x equal to 2x over x plus 3, y is equal to 2x over x plus 3. Same process, switching x and y gives me x equal to 2y over y plus 3. So I need to solve for y, so I'm going to multiply by the denominator again. Anytime you have a fraction, that helps take things out of the fraction component. So multiplying by y plus 3 on both sides. I think they're having a party outside my office here. I'm sure you guys can hear it. So multiplying by y plus 3 cancels it on the right hand side. On the left hand side I'm going to distribute, so xy plus 3x, and I have 2y on the right. Now I can't solve for something when it's on both sides of the equation. So I'm going to take my 2y and move it over to the other side, and I'm moving this one over here, I'm going to move this one over here, and I'm left with xy minus 2y equal to negative 3x. Now finishing the solution, if I have y in both components and I need a single y, I'm going to factor it out. So y times x minus 2 is equal to negative 3x, and y would equal negative 3x over x minus 2, which is our inverse function. Alright, I hope you have a good lab, and here is an overview of inverses, which we will review on Monday. Thank you.